Good morning, students. Now, today we are starting our next chapter, that is the properties of bulk matter. It's a long chapter, properties of bulk matter. It is the first unit, you can say, in the second book. As I told you that the first book is completed with the rotational motion and gravitation. We have completed it. And now we are starting the second book. In the second book, the first unit is properties of bulk matter. Let us now concentrate on this. Before starting this chapter, I just tell you, properties of bulk matter is a big unit. Rather, you can say it is the longest unit of this our class 11 syllabus. In this, a number of chapters are there. First, we are going to discuss here the important properties of solids, that is the elasticity. After that, the important properties of fluids we shall discuss. And lastly, the thermal properties. With this complete chapter will be closed. So today, I am starting the first chapter, that is the properties of the solids, with the important property elasticity. Elasticity is a very important property of the solid. And what is elasticity? You can write. Elasticity is the property of a substance. Elasticity is the property of a substance by virtue of which elasticity is the property of a substance by virtue of which it is the property of a substance by virtue of which the substance restores its original conditions. The substance restores or regain or tries to regain. I repeat, it is the property by virtue of which a substance regains or tries to regain its original condition. Tries to regain its original condition when the deforming force is removed. When the deforming force is removed. Very simple. I am just giving you a simple example. Suppose you take the case of a rubber string. Normally we say it is elastic. Although it is not perfectly elastic, I will tell you, I will explain it later on. But in a first glance, you can say it is an elastic material. If you stretch it by giving a deforming force, it has been stretched. When the deforming force is removed, it will again come back to its original condition. Right? That means this rubber string here, being an elastic material, what happens? After the removal of the deforming force, it regains its original condition. Such a type of material is called the elastic material, and this property is called elasticity. Just on the contrary, if the substance does not regain its original condition after the removal of the deforming force, such a material is, or such a property is known as, that property is called the plasticity. In case of the plasticity, the substance does not regain its original condition after the removal of the deforming force. So elasticity, and just its contrary, the another property is the plasticity. Elasticity and plasticity, both are important properties. But here, mainly we are going to discuss the elasticity. Let us now discuss some important terms. Let us now discuss some important terms. What are the important terms? So, first, I am starting with a very simple and very fundamental term. Deforming force. Let us now see what is the deforming force. Alright, deforming force. Deforming force is the force which changes the state, which changes the shape and size of a substance. Which changes the shape and size of a substance. So, deforming force is the force which changes the shape and size of a substance. The force, if it is changing the shape and size of a substance, then that force is called the deforming force. Number 2. Another force is, that is the restoring force. This is called restoring force. What is restoring force? Restoring force is here, if a body is acted upon by a deforming force, right, and it changes its shape and size, okay, and after the removal of the deforming force, the body regains its original condition with the help of the restoring force. That means, what we can say, it is the force with which a body regains its original condition. It is the force with which a body regains its original condition, after the removal of the deforming force. Regains its original condition after the removal of the deforming force is known as the restoring force. यानी restoring force एक internal force है, deforming force एक external force है. जैसे ये एक वायर है, इलास्टिक वायर, इसको मैंने खींचा नीचे with the force F, it is an external force, and restoring force will be an internal force, अंदर में लगेगा, right? It is due to its atomic arrangement and all, due to which it is regaining its original condition. And you can write down, for a perfectly elastic body, right, these forces are equal, right? I am coming to that point. Now, number 3, a perfectly elastic substance. What is a perfectly elastic substance? A perfectly elastic substance is that which regains its original condition, promptly and completely. Although I will emphasize on the point completely more, means there should not be a slight deformation also. It will completely recover, it will completely regain its original condition. Such a type of body is called the perfectly elastic body. And mind this, in case of the perfectly elastic body, the deforming force and the restoring force both are equal. In case of the perfectly elastic body, the deforming force is equal to the restoring force. Generally, for the perfectly elastic body, we consider it to be equal. Number 4 is the stress, a very important point, stress. Stress is defined as, you can write, it is defined as the restoring force per unit area. Restoring force per unit effective area. You better write effective area. Restoring force per unit effective area. यानी ये क्या होगा? Stress is equal to restoring force divided by the effective area. Restoring force per unit effective area, that is called the stress. Now, stress, it may be of 2 types, following 2 types. One is called the normal stress and another one is called the tangential stress. One is the normal stress, another is the tangential stress. First of all, let us discuss what is the normal stress. Normal stress means, in case of the normal stress, the restoring force acts normally or perpendicularly to the effective area. In case of the normal stress, the restoring force acts normally or perpendicularly. Normally का मतलब क्या है? Perpendicularly. Normally or perpendicularly to the effective area. normally or perpendicularly to the effective area. So if it is acting normally or perpendicularly like this, suppose I stretch this wire, I have shown here figure, I am stretching this wire, इसको मैं stretch किया, तो क्या होगा? Restoring force किस पर act करेगा? This area. You see, this wire has two types of area. One is the curved surface area and is the flat surface area. This restoring force will act perpendicular to the flat surface. So flat surface is the effective area. कौन सा एरिया होगा? ये जो फ्लैट सरफेस देख रहे हो ना, ये A इसका एरिया है. तो उस केस में F डिवाइडेड बाई A will be the normal stress. In case of the normal stress, it will be restoring force will be normal to the effective area. ये चीज हम लोग यहां पर भी देख सकते हैं, यहां पर भी देख सकते हैं. Suppose it is a elastic sphere. I squeeze it. Okay, and deform it. Its volume is decreased. After release, what will happen? The restoring force will act like this. It is also the normal, because everywhere restoring force is acting radially, and radial direction is always perpendicular to the tangential direction. So ये भी normal stress का ये भी example है. So these are the examples of normal stress. And second one is the tangential stress. To discuss the tangential stress, I am coming to the third figure. We have to discuss the third figure. As usual, the tangential force, in case of the tangential force, the restoring force will be acting tangentially or along the effective area. In case of the tangential stress, the tangential force will be acting along or tangential to the effective area, right? As shown in this figure. See, this is a cube in which the bottom surface A, B, C, D, if I keep it fixed, it's an elastic cube. If it is fixed and we give the force here, F, upper surface, what will happen? Upper surface shifts. ये effective area होगा. For that, what will happen? The vertical surfaces are slanted. Vertical surfaces will be inclined. So this is called, this is the case of the tangential stress. And I am keeping ABCD, this portion fixed, and giving the force a blow on the top surface. So that is force. This is a tangential force. By area, which area will be considered? The top area will be considered. So this is the case of the tangential stress. Some more terms will continue in the next lecture.